So let's deal with supplemental problem 10.3. You can find this problem in the course ebook in the chapter 10 supplemental problems on page 3. Given this PNP circuit with V sub E beyond equal to 0.7, V sub EC sat equal to 0.2, and beta F equal to 100, can you find the voltage V by guessing at the state of the transistor and then to verify that state? Let's guess active and put the model in. To do that, I need to identify the nodes. Here's my emitter, here's my base, and here's the collector. I have 10 volts back to ground. Between the emitter and the base, I have a battery, plus the minus, plus by the E, minus by the B, a V sub E beyond of 0.7. Between the emitter and the collector, I have a current source of beta FIB. It's also the collector current, and that's the voltage across the emitter collector. To verify that this is active, I have to show that I sub B is positive, and V sub EC is greater than or equal to V sub EC sat. Let's analyze the circuit. So the current here is I sub B. I want to solve for I sub B. If I go around this loop, I just have batteries and something that has I sub B in it. So let's do that. So the drop across here with the direction of base current would be a rise in voltage of 390 K times I sub B, a rise in voltage of 0.7, and then a drop of 10. That's this equation here. I sub B then would be 10 minus 0.7 divided by 390 K, and it's 23.8 microamps. Is that greater than or equal to 0? Yeah, so you can check that off. I sub C is 100 I sub B. That'd be 100 times that number, or 2.38 milliamps. I need to verify this is the right size. Let's go around this loop. The current that's in here is I sub C, which I know. It's going to cause a drop, which you actually called this V already. So I know this voltage, don't know this, and know this one. So if I go around this loop, I could solve for the emitter collector voltage. The rise in voltage is 2.2 K times 100 I sub B plus V sub EC is equal to the drop of 10. That's this equation right here. So now I can solve for the emitter collector voltage. That's going to be 10 minus 2.2 K times the collector current of 2.38 milliamps, and that's 4.764 volts. Is that greater than or equal to 0.2? Yes. So the state's verified. Then lastly, what's the voltage V? Well, we already found that. That's going to be this current, 100 I sub B times 2.2 K. And know the value of I sub B, or 100 I sub B, is 2.38 milliamps. Product of that times 2.2 K is 5.236 volts. And this is supplemental problem 10.3.